Hello everyone, this is Satish Shrestha with EasyPower. Thank you for attending this webinar. Today we'll be talking about new features in EasyPower version 9.8, which was recently released. Let's take a look at the overview. The first topic is OnSite. OnSite is a data collection tool used with tablets that is meant to go out to the field, collect data, build your one-lines, take pictures, etc. And we'll be taking a little more deeper look into the details of what can be collected and how EasyPower will be able to import that collected data from the on-site database. Next, we'll talk about IEEE 519 report changes. 2014, there was a revision of limits for current and voltage distortion, and we have updated our 519 report. Next topic is GE's newly introduced threshold zone selective interlocking circuit breakers, or TZSI models. Then we'll talk about transformer cooling classes, which have been updated in EasyPower dialog so that they better reflect the most recent standards for transformers. We've also added some new fields for impedances that assist people wanting to enter more exact data for zero sequence impedances or based on the lost kilowatt mentioned in their equipment report. Next, we'll talk about functional groups. And we've introduced in functional groups new type of behavior of different protective devices working together to function as one whole unit. We've also added CSV file exports to short circuit reports. We've also added new start page, and we have some new in-product tutorials that will assist users in learning how the product works. And finally, we'll talk about the default data and equipment dialog that can speed up your building the one line. First of all, we'll talk about OnSite. So OnSite is a data collection tool used with tablets, and you can collect data, you can build one lines, you can take pictures and link them to individual equipment. You can also tag pictures, you can write your own notes, you can also have freehand sketches, and there's a tool for verifying the data. You see all the collected data in spreadsheet mode. And finally, when you're done with the data collection, you can export the database, and EasyPower can import that. This is just a view of the one line that has been created using OnSite. And this is the data collection dialog for one of the low voltage circuit breakers. And all of these fields can be totally customized by the end user. In order to export the database from OnSite, from the tablet, you click on the export button and save it on a certain folder. Then that file can be taken into EasyPower and imported. So let's take a look at EasyPower here. So from EasyPower, go to File, choose Import, and from Import, select the menu item, Import OnSite Project. Click on the Browse button for the OnSite database. So in this case, this sub-a.onsitedb is the database that was exported from OnSite. Next, we want to name a file. So click on that button and give it a name. For this, I'm going to call it sub-a. So this is going to be saved as an EasyPower database. Click on Import. So while it's importing, it's going to give you a notepad text output result. And once you close that, you will get your one line inside EasyPower. So let's take a look at some of the items that got imported. For example, this transformer. Now, here is a switchgear. This is our switchgear A. So it imports many of the fields here. In this dialog, we also have a view of other items that was collected apart from the field data. You can also take pictures in OnSite, and these are viewed through this Media Gallery tab in the Equipment dialog. We can also add tags through this EasyPower window. For example, let's say we want to tag this switchgear view and give it a name, say elevation. I click on add. So this picture has been tagged as elevation. Next thing, if you have a lot of pictures and you want to filter by the tags, then click on the name of the tag that you want to filter by, and it's going to filter and remove all the other items that you do not need. So to close the filter, just click on the X sign, and you'll get all the pictures back. Now, apart from on-site collected pictures, you can also add new pictures. For example, let's say on this switchgear, I want to add a picture of the meter that was also part of the switchgear. I click on add, and I choose this meter picture here and include. Next, we'll go into collected data. So this is the view of the data that is collected through on-site. It's got 3 different columns. One is the name of the field. Second one is the value that was entered by the end user. And third is any unit that is associated with that particular value. If you've collected any notes from on-site, then you can view it here. In order to add additional notes, you can type in anything you want that describes the particular equipment. So the collected data can be used in EasyPower. After that, once you enter all the data, you can go into analysis mode and carry out your analysis. Next, we'll talk about the IEEE 519 harmonics report. So some of the changes that have been made in the 2014 revision of IEEE 519 standards are there have been some changes to the current distortion limits and the voltage distortion limits. Second harmonic has been removed from the table. So the lowest harmonic is third harmonic, and the limit calculation goes up to the 50th harmonic now. And new limits have been added for the group higher than 161 kilovolts, and for the category, for the ratio, short circuit current divided by the demand load ratio of less than 25, and this group has been added to the tables. In the case of voltage distortion limits, less than 1 kilovolt or low voltage systems have been added in the report. So let's take a look at EasyPower. I'm going to go into harmonics, and again, just a reminder, in order to get anything into the IEEE 519 report, you do have to specify a point of common coupling. For example, in this case, if you look at our circuit breaker, in the circuit breaker dialog, there's a harmonics tab, and you have to check this box, monitor IEEE 519 point of common coupling. And you also have to specify the kVA demand and the ratio. So this is the ratio between the short circuit current and the load demand. In order to generate the 519 report, you have to go to harmonics options. In the text output tab, make sure that your checkbox is checked for IEEE 519 report. Next, we will run the summation calculation. Okay, and if you click on window, you'll see harmonic summation summary report, and this will give you the 519 report. Now, the report will include only those items that have a definition for point of common coupling. So some of the things to note again here is previously this used to be less than 11th harmonic group. Now we have a range of third harmonic to 10th harmonic group. Similarly, the limit is now 50 on the high harmonic side of distortion. Let's take a look at the new item added for very high voltage systems. This has a ratio of short circuit ratio of 10, which is less than 25, and the new item added is defined by the second row here for odd harmonics. So this is the new item that has been included. Similarly, new category has been added for low voltage. That is anything below 1,000 volts. And the limits are shown here for the third, for the odd harmonics. And even harmonics are 25% of the odd harmonic limit. So the voltage distortion, again, these are new items. For individual harmonic frequencies, the limit is 5%, and the VTHD for the entire spectrum is going to be, for that particular group, is going to be 8%. So those are some of the changes that we've made in IEEE 519 report. Next, we'll take a look at GE's new TZSI model. I'm going to open up a dialog, and we have a tab called ZSI. And in this tab, in order to allow for TZSI model, we have to check this box. This may not be available on all equipment, just the newly introduced equipment are going to have it. So you'll have to look at the instruction sheet before you select this checkbox and model it in the one line. So I'm going to go into coordination focus and open up a stored TCC. So this one was selected for TZSI. So in this TCC plot, you'll notice that the short time pickup, short time delay, instantaneous pickup, and the instantaneous response time, they're overlapped between the upstream main breaker and the downstream feeder breaker. So this looks like, oh, they're not really coordinated. But one thing to keep in mind is ZSI is meant for coordinating upstream and downstream breakers, and we will see how they are indeed going to be coordinated. So what I'll do is I'm going to fault this bus, downstream bus. Okay. So once I fault this downstream bus, the way this is simulated is that the downstream breaker recognizes that it's going to pick up and sends a restraining signal to the upstream breaker. And when it does that, the upstream breaker not only does it shift the time delays, it also shifts the pickup by additional 23%. So that's the new design for TZSI. And I'm going to zoom in a bit here. For sending the signal, the pickup point for this downstream breaker is going to be 81% of the trip pickup. So this pickup, this solid line that we see, is a representation for the pickup for tripping the breaker, whereas this small tick mark that we see, that is for sending the signal to an upstream breaker to tell it is restrained. So that is how the TZSI model works for low voltage circuit breaker. Next, we will talk about Merson's newly introduced control fuse unit. The control fuse unit is an assembly of different components. It has the main fuse on the line side, which is a current limiting fuse. Then it has two parallel paths downstream. One is a bypass switch, and the second one is a very sensitive fuse. So in normal operation, what happens is that majority of the current flows through this bypass switch, and the sensitive fuse does not melt because a small amount of current flows through this. This bypass switch is activated by a relay that is installed downstream. So let's say that this is an instantaneous relay used for, let's say, maintenance mode tripping to reduce arc flash. Then when this relay senses fault current, it sends a signal to this bypass switch, which thereby opens up. Once this bypass switch opens up, all of the fault current now flows through this sensitive control fuse, and this fuse melts rapidly. So the net effect is that with this relay tripping this fuse unit assembly, there's a faster response time for the fuse, and that is how arc flash on the low voltage side is reduced. So what I'm going to do next is plot individual TCCs and see what they look like. So this is the sensitive fuse curve just by itself. Okay. Next, we'll take a look at the unit for two fuses. So this is the current limiting fuse at the main, and it is noted by the letter M. The C stands for the control fuse, which is the bottom one. Next, I'm going to plot the entire set, including this relay downstream. Now, I'm going to increase the size of my window by minimizing the ribbon. What you'll notice here is that this fuse curve is now looking different. So this is a composite curve. The bottom section of the fuse curve is represented by the trip time and the pickup time of this downstream relay, whereas the top of the clearing curve for this composite unit is additional time taken for this control fuse to melt. And that includes the time taken by this bypass switch to open after it receives the signal from this downstream relay. I'm going to double click on this fuse curve. This is going to bring up a dialog. Now, this is called relay control fuse group data. So with this, you can change the pickup and the time delay for the downstream relay. So let me do that. From 10, I'm going to change that to 8. And time delay, I'm going to increase that to 0.1. So when I click on the apply button, take a look at how the curve shifts. Okay, so the delay increased and the pickup time shifted to the left. Next, we'll take a look at how to build this system from scratch. I'm going to go back into Database Edit Focus. And what I'll do is enter some fuses and build this assembly. So I'm going to start off with a fuse and a bus. This is at 13.8 kV. And I've got a switch on the right side and another fuse on the left side. Then I'm going to connect them with a short piece of cable. Okay, so this section, the switch is going to be carrying most of the load current. So I'm going to reduce the ratio or reduce the impedances. Okay, then I connect a short piece of cable again here towards the top, connect it to the bus. Okay. Next, this is the main fuse that I need to choose. So I go to Manufacturer, Mersenne, type is current limiting, style is MVCF, medium voltage current control fuse, and then choose the fuse model and the size. So this is the main fuse, so I'm going to choose 65M. Next, I can right-click and copy, right-click and paste. But there's going to be a difference here, and this is going to be a control fuse, so I'm going to choose 65C. Okay. So this is how we build the control fuse assembly. Next thing we want to do is create a functional group. So I'm going to copy from the left side and paste it on the right. Okay. So I've already selected the data here. So the requirement is that the relay for the functional group must have the data defined. It needs to have a device function, and it needs to have some kind of settings there. Right now, we support instantaneous setting because that's going to be used for maintenance mode, instantaneous trip. So I need to choose this assembly and these items. Then I right-click, choose functional group, and choose relay controlled fuse group. So that's what this is going to be called, relay controlled fuse. Okay. Once I do that, I get a dialog. I can choose the group name. This is like the ID name, so I can name it anything I want. And just like for other devices, such as fuses or circuit breakers, you can choose whether to plot the TCC or not. So there's a checkbox provided. The items that are used for this is you need to have a control fuse, which is this downstream part of the group. You also need to have a bypass switch, which is this bypass switch. And you need to define the relay. You need to define the relay function, which we already checked. And you need to have a CT as part of that. So these are the requirements. There's also a short circuit tab. This can be used for TCC purposes, for clipping currents, and for introducing tick marks into your TCC. So that is what the dialog looks like for relay controlled fuse group. Now that I've defined my relay controlled fuse group, if I want to edit anything, here are some of the functions that we have. I right-click on any object within that fuse group, and functional group, I have select. When I choose select, it's going to select all the items that are associated with this group. So you can see the highlighted green part. Again, I'm going to do right-click, functional group. Let's say I want to edit it. Click on edit, and then you can go in and edit this. Finally, if you want to delete the functional group, you can delete that too. But before we do that, I'm going to show you something on the database report. So I click on File and Database. In the summary, you'll see this new item called Groups. So right now, we've got 2 functional groups defined. So what I will do is, I'm going to destroy one functional group. Right-click, functional group, delete. All the individual items are still there. The only thing that is now deleted is the functional group, or the way they interact with each other. So I'm going to check in File, Database, and I have only one functional group left because I just deleted the other one. So that is how functional groups work. Now, next thing we want to do is take a look at how it reduces arc flash value by applying this technology. I'm going to go into short circuit. I'm going to check the arc flash icon. Then I'm going to do a fault here on this main switch here. So I get something like 78.3 calories. Okay. In this case, we don't have a functional group. working properly because we just eliminated the functional group. On the left side, we still have the functional group, which is the relay control fuse group. I'm going to fault share. So I get a total of just 6.4 calories. So that is how we can use this technology to reduce the incident energy on the low voltage side. Next, we'll take a look at some of the changes we've made to transformer dialogues. Based on IEEE standard C57.12 and IEC 60076, we have new cooling classes. These are pretty much the 4-letter classifications. Some examples are ONAN, meaning oil natural, air natural, or ONAF, meaning oil natural, air forced. So these are the new classifications that we have added. For older transformers that conform to older standards, we still have the older classifications such as OA, OAFA, etc. And the forced cooling calculations that we've been doing in the past based on the tables are pretty much preserved, and we have used the equivalent basis for the overload calculations of the forced cooling MVA rating. We've also relaxed some data entry requirements, and we'll take a look at the transformer dialog next. Before we go into that EasyPower dialog, another thing that we've added is a new field in the impedance data for the transformers that is loss kilowatt. So when we calculate the XY ratio, previously we only were using the ANSI curves. Now for more accurate based on particular transformer that you might have, if you have the data sheet that includes the losses, by entering the losses you get a more accurate calculation of XY ratio for transformers. We've also introduced the zero sequence XY ratios, X0 by Z0 or R0. So let's go into this transformer dialog here. We'll take a look at this, the type. So we've got 3 different categories for liquid filled transformers. The O, K, and L are based on the flash point temperature of the oil. So we've got O, K, and L. And we've introduced new classes here, so you can see all of them. You still have the old classification, and they're under oil. Okay. And so since this does not have any forced cooling, you no longer are required to enter a value here. And this is meant for forced cooling or overload kVA rating. Impedance tab. Right now, if you do not enter any data, let's say you do not have the exact data and you want to use ANSI estimates, then when you hit the calculate button, it's still looking at the ANSI curves. And that is going to be pretty much like in previous versions. If you have the exact data for loss, kilowatt, let's say it's 10, then we can calculate the XY ratio based on that. When I hit the calculate button, it's going to update this XY ratio. Similarly, you've got X0 by R0 ratio for line to ground fault or any type of ground fault calculation. The next item we will review is short circuit report. I'm going to go into short circuit focus for this. Click on short circuit report options. So here what I've done is enable the reports for momentary, interrupting, and I've also enabled some equipment duty report. In this case, this is reduced and include all devices. And at the bottom, you'll see this checkbox. So this is a new field here that allows you to export CSV files of these reports automatically. Some end users have their own system of getting the data from the CSV report and include them in their own customized report. So this allows you that flexibility. Okay. Next, what I need to do is fault all buses. So if you look at the window, you will get the typical HTML format report, just like we used to in the past. But what's new is CSV files are created in the same folder. For example, the example file for this case was bigger. So when I fault the buses with the option of export to CSV, then these files are created. So DE1 stands for equipment duty. DE2 stands for equipment duty with all the breakers and fuses and all the devices. And HI stands for high voltage interrupting report. HM stands for high voltage momentary report. And LM stands for low voltage momentary report. So let's take a look at the high voltage momentary report. I'm going to double click on the CSV file, and you can see this table in Excel. So that's what we have for exporting CSV files. Next, we'll take a look at the startup page. So this is the start page that we have. You can turn it on or off just by going to Window. And then you have this choice, View Start Page. Let's take a look at some of the features here. You can create a new one line. You can open an existing one line. You can also open up a project. And recently used one lines are reported on the left side. Resources will take you to some web pages, or it'll open some documents that you are looking for. For example, if you're looking at the user guide, clicking on this is going to bring up your user guide in PDF. And another new feature we have is in-product tutorials. So let's take a look at this. When we do this, we get the tutorial in a slightly compact view, and you can go step through the various items one at a time. So this allows you to click on next button, and then as you continue learning the software, you can click on this button to navigate through the instruction. Similarly, the start page at the bottom has some videos that take us to the website that show the video. Either it could be a training video or it could be some webinar videos that we've collected over time. Next, we'll take a look at equipment dialogue. Let's say you're building the one line, and when you're doing that, you may come across some equipment that are more common than others. For example, let's say you've got a cable, and for this cable, you start entering the data. Say you're entering 1/0 cable of the RSW insulation type. And what you can do to save time is, if you've calculated everything except the length, because the length can vary for different feeders, what you can do is click on this default, save default button. So I'm going to do that. So this will override default equipment data. I'm going to say yes to that. Then I enter the length, say this is 75 feet, and click OK. Next time I want to enter a new cable, what you will get is whatever you stored as the default gets saved with all the calculations. So all you need to do now is just enter a new length. So say this is 120 feet, and that's all I have to do. So this helps you in quickly adding new items that are very common while you're building the one line. Now, another feature that is available here is, let's say we've got a different cable here. So in this cable, if you want to, restore to the default data, then all you need to do is click on this button on the right, and it's going to bring in the default data. So that's your default data there. So those are some of the new things that we've introduced in EasyPower version 9.8. If you have any questions, please do contact us. And we have on-site descriptions posted on our website. There are some videos too, so feel free to visit our website and learn more about this. If you have any questions, please do contact us and let us know what your questions are. Thank you very much.